Okay, now display the content of the heap. So it's a very simple array. array Array A holds the data like this way. So first will be the 71, 2, 3, 4, 5, 6, 7 and 8. So 70, 41, 2, 3, 4, 5, 6, 7. Array index starting from 1. 63, 13, 9, 7, 33 and 2. So 8 elements are there. You just display the array from 1 to n. So it will display 70, 40, 63, 13, 9, 7, 33 and 2. Now int heap maximum. So how to know which one is the maximum value? Just return the A1 value. So A1 value, the root holds the maximum value. Okay, and if it is a min heap, then A1 will hold the minimum value. Now void heap extract. So heap extract means what? Extracting the maximum value from the heap. Now okay, so it's a max if n less than 1, the heap is underflow. If no data is present, so we can't delete. So max is equal to A1. So what is max? A1. So A1 is what? This is 1, 2, 3, 4, 5, 6, 7, 8, 70. So 70 is the maximum value. Okay. Reduce the heap size. Okay. Sorry. A1 max is equal to A1. So max value is 70. Then transfer AN value to A1. So what is AN value? So AN is equal to 8. So 2. Now it is 2. Okay. N minus 1 means what? Reduce the heap size. Now this particular portion is not part of the heap now. Okay. Now the extracted data is what? 70. Apply maxify. If you have a maxify, that means we have to convert this tree into maxif once again. Okay, so it is not in heap, it is not maxif because the root is smaller than 40 and 63. It is not maxif. So compare these two. So swap with these two, compare these two, then 33 and 2. That means after that the tree will be 63, 40, 33, 13, 9, 7 and 2. This is the function, these two are the function through which, these are the functions through which we can insert value. Okay. Here we want to increase the key value. Suppose the I is equal to 5 and key value you want to insert 50. Now key is less than AI. What is AI? A5. Key is say 50 and AI is 2. The condition is false. Now if the condition is, suppose you want to modify 2 to 1, so we can't modify this, we can't change the value of 2 to 1 because we can't insert, we can't reduce the value. AI is equal to key. So what is key value? 50. So make it 50 here. Okay. Now while I greater than 1, yes, condition is true. Now if parent content of the parent is more than this, condition is true, to swap with parent. So it is 50 and it is 40. So after that, okay, and I is equal to parent of 5. Now the I is equal to 2 and I greater than 1, condition is true, but if parent is less than the the AI, the condition is false because parent is 90, it is 50. So after that the tree will be 90, 50, 7, 13 and say 40. Now suppose we want to insert, so I is equal to 1, 2, 3, 4, 5. Now in fourth index we have to convert this 13 to 133, suppose. Then key value is what? 133. Key is less than AI. What is AI? I 4 is 13 and key is what? 133. The condition is false. The condition is false means AI is equal to key. So now 13, convert this 13 to 133. Now the value of this part is what? 133. I greater than 1, condition is true because I is equal to 4. Is parent is less than the AI? Parent is what? 50 is less than 133. Condition is true. So swap the content with the parent. Now it is 133 and it will be the 50. I is equal to parent of I. Now the I will be the 2. So it is 4, now it is 2. Okay, I is equal to 2. I greater than 1, condition is true. Is parent less than AI? Parent is 90, it is 133. Condition is true, swap this one. Now it is 133 and it is 90. I is equal to parent of 5. Now I is equal to 1. Okay, I greater than 1. The condition is false because I is equal to 1. Come out from the loop, return. Now after that, the tree structure is what? 133. Okay, 97, okay, 50 and 40. Now this one is what? Inserting data into the max. Now key, suppose you want to insert, say 70. Increment the heap size. Now this particular part will be the heap and insert our negative value, say negative 999. Apply heap increase key. Apply this particular function to this one. Now key you want to insert, suppose you want to insert say 70. Now if you want to insert 70 here, yes, you can insert. Then compare these two. So this will be the 70 and this will be the 7. So after that 133, 90, 70, 7, 50 and 40. Now suppose we want to insert 12. So how to insert? First increase its size, put one small number. Now the key value is what? It is 12. So put 12 here, compare with the parent. The condition is false because the parent value is more than this. Keep as it is. Suppose we want to insert, say, value 200. Suppose we want to insert value 200. Now increase its size, put one small value and apply this particular function. Okay, so if you apply this particular function, now it will allow to insert into the 200 because 200 is more than minus 999. Just check this particular condition. So this will be the 200 first, then compare these two. So root value is parent value is more than this, so swap this one. Now it is 200 and it is 50. Then once again compare these two. So now it is 200, it is 90. Then compare these two. So now it is 200 and it is 133. So after this operation, 200 will be the root. Then 133 will be the left child, 70 will be the right child, 90 will be the left child, 40 will be the right child, 50 will be the left child. Okay, 7 is the left child of 70 and it is 12. So in this way we can insert data into the heap tree, max heap. Okay, and thank you very much. Now the application of binary heap tree. Now binary heaps are mainly applied for sorting an array using heap sort algorithm. Okay, and implementing the priority queues. Okay, thank you very much.
Okay, heap tree implementation. This is the parent part. So parent part, it will return the address of the parent. It will return array index of the left. It will return array index of the right child. Now this is the heap max heap algorithm. Okay, this is the max heap part. This is build max heap. Okay, so this is what heap sort algorithm. Now to display the heap, okay, and say heap maximum and display the maximum value, heap extracted, so delete a heap maximum value from the heap. Okay, and the main function So 1 to create, 2 to display, 3 to sort, 4 to display, 5 to reveal the max, 6 to extract, and 0 to exit. Now if case 1, call the build max heap function and display the, in case 2, heap maximum, and so on, and end of this particular main program. Now you can run. So to create a tree, heap tree, suppose enter the 5 data into the array. Suppose first data is 18, next say 22, then 56, then 3, then 2. So the maximum is 56. So the tree is 56, 22, 18, 3, 2. Now 56 is the root, left child is 22 and right child is 18. Under 22, left child is 3 and the right child is 2. So in this way you can build the max heap. Now 2 to display the maximum. So the maximum is 56, so it will print the 56. 3 to, so to create a heap, enter the 5 data. Suppose 19 first, then 22, then 3, then 24, then say 4. So the maximum value is 24. So 24 is the root, left child is 22 and the right child of 24 is 3. Now left child of 22 is 19 and right child of 22 is 4. Now the maximum value is what? 24. 3 to sort, so it is a sorted value 24, 20, 22, 19, 4, 3. And to rebuild the max heap, you just press 5. Now the rebuild the max heap. Now extract the maximum value 6. If you press 6, then it will remove 24 from the tree. Now the extracted data is 24. Now you can display the tree. Now 24 is not part of the tree. Now you can extract another value 6. Now 22 is extracted. Now if you see,